Hi everyone, I'm Sai Haran from BTech 21 Electrical Batch, and welcome to the seminar on the history of telegraphy. So, quickly going over things we'll be talking about. We'll first start off with why telegraphy for this seminar, and then move on to the early telegraphy methods, and then into how telegraph impacted society, politics, military, press, industries, and then finish it off with the decline of telegraphy. I'll also be talking a bit on how it affected India. So, why telegraphy for this seminar? The telegraph was one of the first electrical communication technologies, and it played a key role in the development of electrical engineering as a discipline. The development of telegraphy required the construction of long distance transmission lines, which led to the advancements in power transmission and distribution. The telegraph was also one of the first applications of electrical communication that required the use of electromagnetic theory and its applications like signal amplification, transmission, or reception. The development of telegraph also paved way for a lot of other electrical communication technologies like telephone, radio, television, and so on. It also played as an important driver for automation and industrialization, as it enabled faster and more efficient communication between businesses, government agencies, individuals, and it facilitated growth of commerce and industries like never before. Moving on to the pre-telegraph communications that were in place, it was primarily limited to face-to-face interactions, written letters, and messenger services. Communication over long distances was, as you guessed, very slow, unreliable, and often depended on the weather and other external factors. Written letters were also primary means of communication for long distances, but they could also still take weeks or even months to deliver. Messenger services like carrier pigeons or human runners were often used to deliver urgent messages, but again, they were also slow and unreliable. Maritime flags and signal fires were used to communicate between ships on coastlines. They were pretty good, but again were limited in how much data they could transmit. Smoke signals and drums were also used by some indigenous cultures to as visual and auditory communication methods over long distances. Semaphore systems, which is using a series of flags or mechanical arms to send coded messages over long distances, were also developed in the early 19th century, but again were limited to their range and speed. These were mostly used for military and maritime communications. For example, like if the flag was at a horizontal position, it could mean that the enemies are approaching, or if the flag was at a vertical position, it could mean that they needed more backup, something like that. These visual telegraph systems came in different ways. For example, in the first image, you can see how Ireland adapted it. Each of those arrows could point in 8 different ways, which means they had four digits that they could transmit. And they referred this to a code book to decipher what the message was being sent. And then you have what United Kingdom did. The di- diagram of UK's Murray 6 shutter system is shown, where each of the shutters could either be flapped closed or flapped open to transmit a certain message across long distances. Moving on to the early methods of electrical telegraphy. From early studies itself, people knew that electricity travels with great speed, and many experimenters already worked on the application of electricity for communications over long distances. All of these known effects of electricity, like sparks or electrostatic attractions, chemical changes, electric shocks, and even later electromagnetism, were applied to solve the problem of controlled transmission of electricity over various distances. In 1753, an anonymous writer in the Scots magazine suggested that electrical telegraph was a possibility, and he used one wire for each letter of the alphabet, and then a message could be transmitted by connecting the wire terminals to an electrostatic machine and observing the deflection of the pith balls at the far end of the receiver. In 1774, Georges Louis Lesage realized an early telegraph machine. This telegraph had separate wire for each of the 26 letters, and the range was only between two rooms of his house. And in 1800, Alexandro Volta invented the voltaic pipe. and this provided a continuous source of electricity for experimentation. It was low in voltage, but since it was continuous, it could be used to produce more distinct effects, and it was far less limited than the momentary discharge of an electrostatic machine, which the Leyden jars were using at that point of time. Another very early experiment in the electrical telegraphy was the electrochemical telegraph, and it was created by a German physicist, anatomist, and inventor, Samuel Thomas von Sommering, in 1809. And it was based off an earlier and less robust design of the same thing in 1804 by a Spanish polymath and scientist, Francisco Salva Campillo. Both of these designs employed multiple wires, sometimes up to 35, to represent almost all the Latin letters and numerals. Thus, messages could be conveyed electrically up to a few kilometers in Sommering's design, and each of the telegraph receiver's wires were immersed in a separate glass tube of acid. An electric current was sequentially applied by the sender's end through various wires, and it each represented a letter of the message. And at the recipient's end, the current electrolyzed the acid in the tubes, and in the same sequence, releasing streams of hydrogen bubbles next to each other, associated with the letter or the numeral. The number of great scientists who worked on telegraphs is unimaginable. All the 19th century inventions and discoveries around electricity went into making the telegraph. Oersted discovered in 1820 that an electric current produces a magnetic field and that will deflect a compass needle. And in the same year, Johann Schwinger invented the galvanometer with a coil of wire around a compass that could be used as a sensitive indicator for electric current. Also that year, Andre Marie Ampere suggested that telegraphy could be achieved by placing small magnets under the ends of the set of wires, one pair of wires for each letter of the alphabet. In 1825, Peter Barlow tried Ampere's idea, but he got it to work only over 200 feet, that's around 61 meters, and he declared it impractical. And in 1830, William Ritchie improved on Ampere's design by placing magnetic needles inside a coil of wire connected to each pair of conductors. He successfully demonstrated it, showing the feasibility of electromagnetic telegraph, but he did it only within the bounds of a lecture hall. In 1825, William Sturgeon invented the electromagnet with a single winding of uninsulated wire on a piece of varnished iron, which increased the magnetic force produced by electric current. Joseph Henry improved it in 1828 by placing several windings of insulated wire around the bar, creating a much more powerful electromagnet and could operate the telegraph through the high resistance of long telegraph wires. During his tenure at the Albany Academy from 1826 to 1832, Henry first demonstrated the theory of magnetic telegraph by ringing a bell through 1 mile of wire strung around his room in 1831. Now, coming on to Morse code, the Morse system uses a single wire between offices, and at the sending station, the operator taps a switch, which is called the telegraph key, spelling out messages in Morse code. You might have seen this code throughout my presentation as a tribute to the creator Samuel Morse. Originally, the armature was intended to uh, make marks on a piece of paper, but later operators started to interpret the clicks directly, and it was way more efficient to write down the message. In early 1830s, Morse was traveling on a ship from Europe to US when he overheard a crew talking in code. This fascinated him and made him create his own code to send messages. This code was initially made of just dots and dashes, which was called dits and das. And he assigned each of these combinations of dits and das to each letter of the alphabet. And as well, later added the numbers and punctuation marks as well. Morse tested his code by sending messages over a wire between two of his rooms in his apartment building in Washington, D.C. Over time, Morse refined and expanded his code, added special characters and other modifications, like making sure that the most used letters had lesser number of dits and das. In 1851, a conference in Vienna of countries in the German-Austrian Telegraph Union, which included many of the Central European countries, adopted the Morse telegraph as the system for international communication. What hath God wrought? This phrase is taken from the Bible, specifically from the book of Numbers 23:23, and it means what has God created or what amazing things has God brought about. The use of this phrase in the telegraph message was meant to convey the incredible feat of transmitting a message over long distance through electrical wires, which was groundbreaking achievement at that time. Today, the phrase is more often used to generally refer to any significant and impressive accomplishment. In the next slide, I'll actually play an audio of the Morse code just as how the operators used to listen while they were writing down their messages. That was pretty fast, right? Yeah. Over practice and time, operators found that listening to the Morse code like this was a way more efficient method to write the messages down than like read it through dots and dashes on a piece of paper. After this comes the Foy brigade system. France was kind of slow to adopt the electrical telegraph. This is because they were extensively using the optical telegraph that was built during the Napoleonic era. There was also a serious concern that an electric telegraph could be quickly put out during action by enemy saboteurs, something that was much more difficult to do with optical telegraphs. This was because there were no wires or there were no hardware exposed between two stations. The Foy-Brega telegraph was eventually adopted. This was a two-needle system using two signal wires, but displayed in a uniquely different way to other needle telegraphs. These needles made symbols similar to the Sharps brothers' optical telegraph systems, and it was way more familiar to the telegraph operators. This optical system was decommissioned starting in 1846, but not completely removed until 1855. In that year, Foy-Brigade system was replaced by the Morse code. Following this comes the Cook and Wheatstone system. So in this, there are like five needles, and based on how each of the needles are positioned, they correspond to a certain letter, as it's shown in the figure on the left. Uh, the major advantage of the system was that it directly displayed the letter being sent, so the operators didn't have to like learn a code. But this system suffered a failing from insulation on the underground cables. When the line was extended all the way to Slough in 1843, the telegraph was converted to a one needle system with two wires, uninsulated wires on poles. Later, they found the cost of installing these wires was way more than training the operators, so they stuck to the one needle system. This one needle telegraph proved highly successful on British Railways, and around 15,000 sets of these telegraphs were still in use at the end of the 19th century. Some of them remained in service up to the 1930s. And the Electric Telegraph Company, the world's first public telegraphy company, formed in 1845, was also by Cook and another financier, John Louis Ricardio. Following this comes the ABC Wheatstone Telegraph, and I will quickly play a video of it to give you an idea of how it works. As you could see in this ABC Wheatstone telegraph, this was developed as a practical alphabet system in 1840, and it was mostly used on private wires. This consisted of a communicator at the center send and an indicator at the receiver side. The communicator consisted of a circular dial with a pointer and the 26 letters of the alphabet, along with the four punctuation marks around its circumference. Against each of these letters was a key that could be pressed. A transmission then began when the pointers of both the dials were at the start position. The transmitting operator would then press down on a key corresponding to the letter, And then at the base of the communicator, there was a magneto. So this was actuated by the handle in the front. This would then be turned to apply the alternating voltage to the line. And at each half cycle, the current would advance to the pointers at the end by one position. When the pointer reached the position of the pressed key, it would then stop and then the magneto would be disconnected from the line. The communicator's pointer was geared to the magneto's mechanism. The indicator's pointer was moved by polarized electromagnet whose armature was coupled to it through the escapement. Thus, the alternating line voltage moved in the indicator's pointer on the position of the depressed key on the communicator. Pressing another key would then release this pointer from the previous key and then reconnect the magneto to the line. These machines were like very robust and simple to operate, and they stayed in Britain until well into the 20th century, and most of the private people also used it. We now move into the oceanic telegraph cables. Soon after, like the first successful telegraph systems were operational, the possibility of transmitting messages across the sea by way of submarine communication cables were proposed. And one of the primary technical challenges to this was sufficiently insulating the submarine cable to prevent the electrical current from leaking into the water. In 1842, Scottish surgeon William Montgomery introduced gutta percha, an adhesive juice of the Palacium gutta tree, to Europe. Michael Faraday and Wheatstone soon discovered the merits of this gutta percha as an insulator, and in 1845, the latter suggested that it should be used to, to cover the wire which was proposed to be laid from Dover to Calais. Gutta percha was used as an insulation on this wire, and in 1849, C.V. Walker, electrician to the Southern Eastern Railway, submerged a 2-mile wire coated with gutta percha, which was tested successfully. Now, enough with the technicalities and the names and years and when things came. Let's move into the more social uh, effect telegraph had on the society and industry. So, during the 1900s, the market leaders in telegraphy were the companies that had established themselves as dominant players. And these included like Western Union in the United States, which had become the largest telegraph company in the world by late 1800s, and the Eastern Telegraph Company in the United Kingdom, which had built its empire over extensive network of telegraphs through the British Empire. There were other significant players in the telegraph industry during the early 1900s, that included the French Telegraph Company, which operated its telegraph network in France and had its presence in like other parts of Europe and Africa, and the German Reichspost, which operated the telegraph and postal services in Germany. We now move into the impact of telegraphy on society. So, the telegraph played a very significant role in facilitating the centralization of power in governments and businesses. So, before the telegraph, it was difficult for coordinating operations over long distances, which meant that power and decision making tended to be more decentralized. But with the advent of telegraph, it became easier for leaders to communicate with their subordinates over long distances, allowing them to coordinate operations more effectively and centralize power. In the business world, the telegraph allowed companies to coordinate their operations across multiple locations, giving rise to large centralized corporations with complex management structures. This was particularly evident in the transportation and communication industries, where the large companies like Western Union and railroads came to dominate in their respective markets. From the eyes of the government, telegraphs made it easier for them to respond to crisis more quickly, but it also had the effect of consolidating power in the hands of a few key individuals and institutions. Overall, the telegraph played a significant role in facilitating the centralization of power in both governments and businesses, and setting the stage for the development of even more centralized forms of organizations in the years to come. While this trend had a lot of benefits like increased efficiency and faster decision making, it also raised concerns about the theory of centralization of power and the potential for the people in power to abuse it. Another aspect of the telegram was that it was often used to send the message of the loss of a close one. So men who went on war often had their families receive a telegram, and it never meant good news. This telegram, the death telegram, was priced at one-fifth the original price, and a few of those images are shown on your screen. Let's talk about telegraph and politics. One interesting story that illustrates how telegraphy affected politics is the case of the 1860 presidential elections in the US. The election was hotly contested between four candidates, and the outcome was uncertain till the final votes were counted. On the election night, November 6th of 1860, the telegraph played a crucial role in transmitting the results of the election to the rest of the country. As the votes came in, telegraph operators relayed these results to newspapers and political leaders, who closely followed the progress of elections through these telegraph reports. At that time, the US was divided by regional interests and tensions, with the northern and the southern states often at odds over issues such as slavery and states' rights. As the election results came in, it became clear that Abraham Lincoln, the candidate from the Northern Republican Party, won the elections. This news was transmitted rapidly across country via telegraph, allowing people to learn of the outcome within hours of the polls closing. This speed and efficiency played a significant role in shaping the political landscape in the aftermath of the election. This news of Lincoln's victory spread quickly, triggering a wave of reactions and responses from politicians and citizens alike. Some southern states felt that their interests were not being represented in the new government, and they began to talk about it from the Union. This ultimately led to the outbreak of the American Civil War, which would reshape the country's entire political landscape and lead to significant changes in the government and society. Overall, the telegraph had profoundly impacted the way politics was conducted, both in the United States and around the world. It allowed for faster and more efficient communication, which helped shape the course of major political events and allowed governments to respond quickly to crises and challenges. Talking about how telegraph affected the military, the ability to send telegrams brought obvious advantages to those conducting war. Secret messages were encoded, so interception alone would not be sufficient for the opposite side to gain advantage. There were also geographical constraints on intercepting telegraph cables that improved security. But once radio telegraphy was developed, interception became far more widespread. An electrical pathway is the route for current to travel, but by manipulating this phenomenon, the Enigma machine was able to scramble messages. The mechanical parts act by forming a varying electrical circuit. But when one or more keys are pressed, the rotors rotate and create a unique combination of electrical pathway for the signal to go through. When the other end also had the same configuration, this signal led to the led to the corresponding light to glow, which shows the output letter. One interesting story about the telegraph and the press is the assassination of President Abraham Lincoln in 1865. At the time of Lincoln's assassination, the telegraph had been in use for several decades and was a vital tool for the news industry. When the news of the assassination broke, newspapers all over the country relied on telegraph wires to transmit the latest updates and details to their readers. In particular, the Associated Press (AP), a news agency that had been formed in 1846, played a crucial role in disseminating news about the assassination. The AP had reporters stationed in key cities across the country, and they were able to quickly gather information about the shooting and the subsequent manhunt for John Wilkes Booth, the assassin. Thanks to the telegraph, the AP was able to transmit this information to newspaper and other media outlets around the country, allowing them to provide their readers with up-to-date and accurate information about the tragedy. This helped to shape public opinion and response to the assassination and contributed to the national mourning that followed. This story also illustrates the importance of accuracy and reliability in news reporting, as the AP took great care to verify its sources and fact check its stories before transmitting them over the telegraph wires. It helped to establish the AP as a trusted source of news and helped to set a standard for responsible journalism that is still in place today. We finally come to the decline of telegraphy. In America, the end of telegraph era could be associated with the fall of the Western Union Telegraph Company. Western Union was the leading telegraph provider for America and was seen as the best competitor for the National Bell Telephone Company. So, when Western Union and Bell were both invested in the telegraph and the telephone technology, Western Union's decision to allow Bell to gain advantage in telephone technology was the result of Western Union's upper management and their failure to foresee the surpassing of telephone over time and be more dominant than the telegraph system. Western Union soon lost its legal battle for rights over their telephone copyrights, and this led to the Western Union agreeing to a lesser position in the telephone competition, and in turn led to the loosening of the telegraph system. The first communication via telegraph in India happened in 1850 between Kolkata and Diamond Harbour, which is around 50 kilometers from the main city. During its final years, the service was able to garner a revenue of around 75 lakhs annually, but the running cost was around 100 crores. This led to the last telegraph in India being ever sent from the city of Nagpur on July 14th, 2013 at 11:55 p.m. It was sent by Kavita Vaghmare to her mother, and in it she wrote a poem wherein she praised and saluted her mother's love and the telegraph staff for its 163 years of long service, and lastly saluted motherland India. Those of you who are now interested in telegraphs and want to learn more about it can look through these references. And thank you to Mr. Dilip Nair for coordinating this course, and thank you for listening to me.